Hi friends, my name is Sanjay and welcome to my YouTube channel. So in this series, in this mathematics for machine learning series, in this video, we'll be discussing LP norm or Minkowski distance. The LP norm is a generalization of all the norms, that is L1, L2 norms. So basically, you have the P as a parameter. You can change the value of P to get L1, L2 norm and other norms as well. So we'll see the general formula. Then we'll see how we can get the other norms that we have discussed from this general formula. So let's dive deep into it. So let's look into the LP norm or the Minkowski distance. The LP norm is basically generalization of all the norms. So we discuss L1 and L2 norm. LP norm is generalization of both of them. And you can have any kind of other norms. Like from this, you can calculate L3, L4 norms. Basically, this is general formula from which you can derive other norms. So to represent the LP norm, we have this, we are using this two vertical lines on both sides, right? So we have this AB vector, we're having these two vertical lines on both sides to represent norm, and we are having subscript P to represent the uh, type of norm. So LP, so P here, if it is L1, then 1, if it is L2, then 2. Basically, the P is a parameter that you can replace. You can have P equals to 1, P equals to 2, P equals to 3, and so on. But P equals to 2 is the most common one, and then P equals to 1, that is the Manhattan distance, is the second common. Anyway, let's look into the Minkowski distance or the LP norm as well, just for completeness. So this LP norm is equals to Minkowski distance between point A and point B. Okay, this is generalization of all the norms and all the distances. So the formula for LP norm is you take the summation of absolute value of wi summation of I equals to 1 to n. So basically you sum over all the components of the vector and you take the absolute value of wi, so absolute value of the each of the component, and then you take to the power p. Okay, so absolute value of wi to the power p, you sum them up and then you take to the power 1 by p. Okay, so that's the general formula for LP now. So from here you can derive the L1 now, right? So if you have P equals to 1, so here we will have 1 by 1, that is 1. So we can ignore this. Here also we'll have P equals to 1, that means here we'll have 1, right? So you can ignore this one as well. Basically it will be, basically this one, it will be summation of absolute value of Wi, which is the formula for L1 norm that we have seen earlier. And similarly, you can derive the formula for L2 norm from this as well. You take the square here, you take the, uh, if you put P equals to 2, right? So P equals to 2 here and then P equals to 2 here, you get the formula for the L2 norm. Basically, we are taking absolute value and then squaring, right? This is slightly different, but if you see, the square will anyway give you the positive number, right? It won't give you negative numbers. So taking absolute value and squaring or directly squaring is the same thing. So you see this is the same formula for L2 now. Same as the L2 now formula, right? So that's how you get the L2 norm formula from LP norm. Similarly, you can calculate other norms as well. So basically, if you calculate L3 norm, you'll have cube here and then you'll have cube root here. And similarly, you can see the formula for Minkowski distance. We are taking to the power p here and we are taking to the power 1 minus p here. And this subtraction will give us the wi, right? We are taking the absolute value and then sorry, we are taking the absolute value and then we are taking this uh, to the power p. So this is the formula for Minkowski distance. This is generalization of other distances such as Euclidean and Manhattan distance. So if p equals to 1, then Manhattan distance or L1 norm. If p equals to 2, then Euclidean distance or L2 norm. Uh, As I have mentioned earlier, right? If you don't have any subscript here, generally you won't see subscript here in many books. If you don't have any subscript here, you can assume that's a two by default. So two is the default subscript. That means it's L2 now. So when you have somewhere in the book or in a research paper, uh, norms mentioned like this without any subscript, then you can assume L2 now. Thanks for watching. If you need any clarification on this, please comment. See you next time. Bye.